Holiday Maths number 5, the solutions. Picture me sitting in my kitchen. It's dark outside and we're about to do some maths together. Right, so the question says a sequence is given by x1 equals 1, that's the first term, and then xn plus 1 is equal to xn times p plus xn. So what we've got here in English is the first term, and we've got the next term rule. So it says find x2 in terms of p. So notice that x2, the little number at the bottom, so that must mean n here is 1 plus 1, and then we've got x1 times p plus x1. Okay, I don't know if you can see I've done that, but I know what x1 is because they told me at the start. It's right there. So x2, the second term, is equal to 1, because that's the first term, times p plus 1. So x2 is equal to p plus 1. And there's 1 mark for that little beauty. Now, what do they want us to do next? It says show that x3, the third term, is equal to this thing here. So x3, the third term, well, that's going to be x2 plus 1. Notice I'm just having a look here really. So that's going to be the second term, x2 times p plus x2. And I know what x2 is because it's my answer to the last bit, so I can write down the third term is equal to the second term, which was p plus 1, times p plus 1. If this is doing your head in, then just pause it and have a little look. All I've done is I've substituted this thing in for the x2's here, and now I'm just going to multiply it out and tidy it up really. P plus 1, and then I've got 2p plus 1 in here, and if I multiply those out I get 2p squared plus 3p plus 1, which is what they wanted me to show there, so that's it. QED, it has been shown, it has been demonstrated, quae demonstrandum. Now, there's a new piece of information turn up here. They've just told us that the third term equals 1. Find the value of p. Well, it happens to be that the third term also equals this quadratic, so I can say that this quadratic, 2p squared plus 3p plus 1 equals 1, and subtracting 1 from both sides leaves 2p squared plus 3p equaling 0. And then I can take a factor of p out, and I get 2p plus 3. Therefore, p either equals 0 or p is equal to minus 3 over 2, which is minus 1.5 for those of you that like decimals. Now the question is, it says find the value of p. So we go back up to the top and we discover that p is a constant and p is not equal to 0. So that means we need to be very clear and identify this as p is not equal to 0. Now, 2 marks for the last bit. A little bit tricky perhaps, and this comes from really understanding what's going on here. Now, clearly, this is not something we can work out easily, especially since core 1 is non-calculator, so there must be a trick, especially since they say write down. That's basically code for saying it should be obvious. So let's have a look at the sequence. x1 is equal to 1. Now x2, the second term, is equal to 1 times p plus 1. Now p was minus 1.5 plus 1, and that gives minus 0.5, And then the third term is minus 0.5 times minus 1.5 plus minus 0.5, which works out to be 1. And because the fourth term depends on the previous term, that's going to be equal to 1 times minus 1.5 plus 1, which is minus 0.5. So you can see there's a pattern, and it goes from 1 to minus a half to 1 to minus a half. It's an oscillating sequence, and the even numbers are minus a half and the odd numbers are ones. This is an even number, so we can fairly safely say that the 2008 term is going to be equal to minus 0.5 or minus a half, and that's our 2 marks. Now a bit of core 2, the remainder theorem. Find the remainder when this cubic is divided by x minus 3, and the remainder theorem is very straightforward to use. You don't have to do division here. It's much more straightforward to use the fact that if you put in 3, you will get the remainder. So I'm just going to substitute 3. Whatever this is, you just reverse the sign basically. So I've got 3 cubed minus 2 times 3 squared minus 4 times 3 plus 8. And you stick that in your calculator and out will pop the number 5. Really doesn't want to be there, does it? Now, this time here we just stick in the number minus 2, and what will come out will be the remainder when we divide by this. So we've got minus 2 cubed minus 2 times minus 2 squared minus 4 times minus 2 plus 8, and that turns out to be 0, and that's significant. We can say therefore x plus 2 is a factor. If there's no remainder, then there's a factor. Then the thing you've put in is a factor. So, hence or otherwise, find all the solutions to this equation. Well, we've just found a factor there. So if we divide this cubic by that, what we'll end up with is a quadratic, which we can factorise. So we are going to divide it. We're going to start with x plus 2, which we know is a factor, and then we're going to divide this cubic, x cubed minus 2x squared minus 4x plus 8. So x's into x cubed go x squared, and then we multiply it back through. X squared times x is x cubed, and x squared times 2 is positive 2x squared. And we subtract to get minus 4x squared, and we bring the next bit down. X squared times x, my bad, sorry, we divide now. X's into minus 4x squared is minus 4x, and now we take this and we multiply it by that to get minus 4x squared, and then we multiply it by that to get minus 8x. Then we subtract. Now that's 0. Minus 4 minus minus 8 is positive 4x. And then we bring the 8 down and we say x is into 4x go positive 4. Then we take the positive 4 and multiply it by this to give 4x, and that to give 8. And then when we subtract we get 0, which we should do because this is a factor. Now this is telling us that our cubic up here, let's call it f of x for sake, is equal to x plus 2 times the quadratic we've just got, minus 4x plus 4, and then we can factorise that quadratic, and it That's a nice straightforward quadratic to factorise. It's going to be minus 2 minus 2, which means we can solve it. X is equal to minus 2, or x is equal to positive 2. And that is that. So have a good evening. I hope you got it right. If you didn't, this is definitely an area which people could do with a little bit more work on, and I hope you're keeping up with me.